Okay, another example. How many grams of sodium and chlorine, respectively, can be produced in 1 hour by the electrolysis of molten sodium chloride in a down cell that operates at 5 volts and 7.5 times 10 to the power of 4 amperes? How many? We are also asked to find the number of kilowatt hours of energy consumed to produce this amount of sodium and chlorine, provided that 1 kilowatt hour is equivalent to 3.6 times 10 to the power of 6 joules. So in this case here, we are given the current, which is 7.5 times 10 to the power of 4 amperes. And we're given the time, which is 1 hour. So let's just convert that directly to seconds. So that's 3,600 seconds. We're given the voltage, which is 5.0 volts. So for chlorine and sodium, so sodium undergoes reduction. Diba? Sa electrolysis sa molten sodium chloride, ang sodium undergo reduction to produce the sodium metal, and ang chlorine kaya mo undergo og oxidation to produce the chlorine gas. So this is plus 2 electrons, and then we put 2 here. So first, we find Q. So solve Q. So Q here is equals I times time. So the current is 7.5 times 10 to the power of 4 amperes times the time, which is 3,600 seconds. So we have Q, that's 2.7 times 10 to the power of 8 coulombs. And then we can now solve for the mass of each. So for sodium, so the mass of sodium, that's Na. So we start with Q, that's 2.7 times 10 to the power of 8 coulombs. And then we know that for every 1 mole of electron, that's equivalent to 96480 coulombs needed. And then from the reaction, we can see that 1 mole of sodium is produced for every 1 mole of electron transferred. And for sodium, the mass, atomic mass, is 23 grams for every 1 mole. Okay, and computing, we will be able to get around 64,365.67 grams of sodium. On the other hand, for chlorine, so the mass of chlorine, so we still start with a charge, 2.7 times 10 to the power of 8 coulombs, and 1 mole of electron transferred for every 96480 coulombs. And from the reaction, we can see that for every 1 mole of chlorine gas produced, there's 2 moles of electrons transferred, and the molar mass of chlorine, Cl2, is 70.9 grams for every 1 mole. So using our calculator, we'll be able to solve around 99,207.09 grams of chlorine. So, muna sila ang masses nga ma-produce sodium and chlorine. And then, for the other one, how many kilowatt hours daw? So, for the energy, it's Q times V, diba? So, QV, so it's 2.7 times 10 to the power of 8 coulombs times the 5 volts, no? And so we are able to get 1.35 times 10 to the power of 9. That's still joules. But in kilowatt hours man daw, so we have to convert nga ang 1 kilowatt hour, that is equivalent to 3.6 times 10 to the power of 6 joules. And so our answer is 375 kilowatt hours. So this is the energy consumed in the production of that amount of sodium and chlorine. So medyo dako sad niya siya. This is 64 kilograms and this is 99 kilograms. And this is the energy consumed in the process.